my name is Dunai, and this is my official unofficial solution for the network state exam. Now it's the 20th topic, which is about the distance vector routing protocol. The operation of distance vector routing protocol is the illustration of the operation on a simple network, so it's quite easy to visualize it, not this. But imagine that we are having one router, we are having another router, and we are having another router, then we are having two hosts, for example. You then connect these together to make a network. Yep. So what's the distance vector routing protocol idea? As its name is indicating, it uses a distance and a vector which will be the direction. So this will be the direction to which, and the distance is simply the metric. For example, at RIP version is the hop count. So basically that's all. It uses a distance and a vector, so the distance from the source to the destination, and the source to the destination, for example, this from a router, then from another, and then so as I said, we have hop count here, for example, if we consider RIP version, and we determine the direction. That's the base of the distance vector routing protocol. The basic configuration of RIP version protocol illustrated on a simple network. So it's quite easy that we are now talking about RIP version 1, I believe, and RIP version 1 is classful network. That means if you would like to if you would like to configure, you will have to add, let me switch to another color, you have to add this network, and you have to add this network. For this router you have to add this network and this network, and what will be the last one? For this router you have to add this network, and you have to add this network. So simply the RIP version, we have to add all the networks that they are seeing, and they are going to exchange update packets within every 30 seconds, where the addresses will be passed, and based on the address, based on the first octet of the address, the network will be calculated. So if we are using RIP version, we have to simply define the networks for the router. Also, it is important that it's good to make this as a passive interface, and this because why would we send an advertisement to this direction or to this direction? Because there are no routers, there are just end devices, and they don't have to use CPU in order to process these advertisements. Therefore, it's worth to make the end devices as a passive interface, and also it will decrease the security risk as well, because don't send unnecessary traffic to the end devices. So this is the basics. It can be time consuming that we have to add all the networks to all the routers. So if there are 100 routers, then it can be really time consuming, and there can be misconfigurations as well. The comparison of RIP version 1 and RIP version 2, similarities and differences. If I remember well, then both of them are using hop count as a metric. If I remember well, the RIP version 2 is able to encapsulate the advertisement packets, meanwhile the RIP version 1 is not using any security on it. The RIP version 2 does auto summarization, or maybe both does auto summarization, but we can turn off if I remember well. The big difference that the RIP version 2 supports the variable length subnet mask and the classless inter-domain routing. That, of course, what I said, that RIP version 1 is classful, and we are able to send with RIP version 2 network on other subnets as well traffic, because there in the advertisements the subnet mask is also provided. Using different versions of RIP protocol in non-continuous network, I already talked about this, but there I said it's classful and classless, but now I just said what's the aim of it, but I believe I had a video in which I showed a concrete example for this, so I'm not going to draw it down again. The concept of integrated multi-protocol routing is the one that I said in the previous one, that imagine we are having or we are using multiple routing protocols, therefore there are multiple destination paths to destination. And for example, of course, here you can come up with the example that I said in the previous video, that the OSPF uses bandwidth and the RIP version uses hop count. So if we are having two routing protocols goes to the same direction, then we will decide based on the trustworthiness. That means that which one is more reliable. The problems and their prevention caused by the topology changes. So yeah, of course here the topology changes considering either RIP version 1 or 2. These are, I believe, not smart routers. I mean, if we add a new router to the topology, we have to define the networks that it can reach, that I've said at the first step, and of course these will not adapt to the topology immediately. So I believe that's the point here. And prevention, I don't know what can be the prevention cause. Not use, I don't know. Use link state routing protocol, I don't know. Authentication of the update messages, configuration of authentication. I already spoke about this, that we can encrypt with recursion to the update messages, but the configuration of the authentication, I don't know what they want here. Maybe they just simply want a simple SSH or telnet here. I don't know. If they want, then of course it's easy. So that's all about this topic. So again, I mainly covered everything, and if I said something wrong, then again I don't really care, and don't forget to subscribe.